afternoon, everybody. This is as part of GATE series of lectures, and this is lecture number 5 as part of AICT Prerana scheme. I'm Dr. Mahbub Basha, Sheikh, Professor and Head Department of CSE, Madanpalli Institute of Technology and Science. And as part of this initiative, actually, I have already given some lectures on this particular topic, which is data structures and programming. In continuation to the earlier lectures, I'm giving here now I'm planning to give on the data structures like stock. I want to give on stock, queue, linked lists, and binary trees, which is binary trees. This is I want to cover, but it may not be possible to cover in one session. It may be some 3-4 sessions. Before I start giving some concepts about stock, queue, linked list, and trees, the way of representing these data structures in memory, first we shall discuss. Then we should start learning stock, queue, and other data structures. So representing any data structure in memory, there are two ways always. Any data structure in memory, we can do in two ways. One is linear representation, another is linked representation. So after what my plan here is, I'll give this way of representing data structure in memory, then stock and queue. Then we'll see the previous problems that are given, in previous GATE question papers on stock and queue. That I want to have a separate lecture. So in this lecture, I want to have the representation of data structures in memory. What are the different ways? Then I'm planning stock and queue. These are these two I'm planning to cover in this session. And when you take the linear representation of data structure, so in linear representation we use arrays, and in linked representation we use linked lists. So any data structure, whether it is stock, queue, tree, graph, anything, we can either represent with array or linked list. In array representation, the thing is all the entire memory, whatever is required, it should occupy in consecutive memory location. So consecutive memory area is required, which is sometimes not possible. That is one disadvantage we can say in array representation. In linked representation, the memory, whatever we use, it may spread across the entire memory. Spread across the entire memory. It need not be at consecutive places. But the accessing speed here, accessing is simple, and accessing is simple. And this is accessing slightly complex. But the thing is, in array representation, mostly we go for a fixed size array. Even if you go for pointer to hold a consecutive memory location, still the memory size is fixed. So fixed memory area. So we cannot, that means here what I meant to say is we cannot grow dynamically. Here, the memory area, whatever we have, it can grow dynamically. So that is one greatest advantage of linked list. So this is main advantage. The linked list can grow dynamically because as and when a data item is node or data item is added to the data structure, we can make it grow. But in array, we should prefix the size, and we had to use only, we had to confine to that allotted area. We cannot go beyond that. That is, it cannot grow dynamically. So this is how we use the linear and linked representation. It is always it is better, or linked list, linked representation is always preferable over linear representation because of the dynamic nature. So that is how we represent. That is one concept required to before any data structure is started learning. Next, when you take stock, stock is a LIFO data structure, last in first out data structure, last in first out data structure, and it is very frequently used data structure. There are a lot of applications of stock. One of the main application that is there with stock is calling the functions, the operating system uses a stock memory, exclusive stock memory with every program, which will be used in uh, that stock memory area attached to every program is used during the call of function, even for recursion, because recursion is part of calling the function. The stock memory area is used. It is very widely used for this purpose. And there are so many other applications, like one of the other application is uh, evaluation of arithmetic expressions. That is actually one of the important topic. So if you take arithmetic expressions, one is generally we go for infix notation. That is our day-to-day life. We use infix, but computer requires the arithmetic expression either in prefix or postfix, preferably postfix. So if we want to convert infix to postfix or prefix, we had to depend on stock. So one of the application of stock is uh, converting infix expression to postfix or prefix, and also evaluation of arithmetic expression. So evaluation of arithmetic expression also requires stock. So there are so many applications of stock present. So but it's a last in first out data structure, and it is already informed that any data structure can be implemented using linear representation or linked representation. Even stock can be done with that. But whatever may be the representation, stock is associated with one data item which is called as top. So stock is associated with one data item top. Always this will be referring to recently filled location, recently filled item. So whether it is linear representation or linked representation, top is always referring to recently filled item, but depending upon what type of representation, either it will be index, it will be index, or it will be a pointer. So if it is linear representation, top will be index. If it is linked representation, top will be pointer. So this is stock is associated with only one data item, which is top. It is associated with two operations mainly. The other operations are optional. So two operations mainly. One is push operation, another is pop operation. Push and pop operations are two operations that are performed with stock. Push is adding item into the stock, and pop is removing item from the stock. So these are the two operations which are performed with stock, and these two operations are performed by keeping this last in first out in consideration. So whichever item pushed last will come out first. That's what the stock does. So adding item into the stock, it is always at the top of the stock, and removing item is always at the top of the stock. So push into the top of the stock and pop from the top of the stock. That's why that's how we perform, and because of this pushing and popping with respect to top. So the stock will be last in first out data structure. Whichever data item inserted last will come out first. Now, when it is a linear representation, suppose if you take stock represented linearly, then we use an array as uh, a medium to hold the data structure, and there will be always top associated with the stock. And initially, when stock is created, top will be -1 to indicate that stock is empty. Stock is empty. To indicate that stock is empty, this is used, and the top is set to -1. These are 0, 1, 2, 3, 4, depending upon the size of the array. Suppose here the size of the array is 5. So now the top will be -1, and when we push, so when we push here, each time, this is the setup in the beginning. So when you push the operations or the algorithm, what we can say here, what we can do here is top is incremented. First, we have to check whether stock is full or not. So if stock is full, so that is one step. And suppose if it is full, then if full, appropriate message is displayed. Message is displayed, and message is displayed, we have to terminate. So end the job, because we are not able to appropriate message should be displayed, and we have to terminate. If it is not full, suppose if it is not full, then we have to increment top, then the next is move item into top of the stock top. So these are the steps to perform, and that is the end. So this is push. Now suppose if I take the push operation, suppose if I am representing using C, and I am having stock as an array of some size, whatever the size is, it does not matter. And suppose if I am declaring globally, I have top which is initialized to -1. Then what we can do with push is, we can say push operation implemented with function. So I can say int item to be pushed. So here you check if top, the first step is to check whether stock is full or not. So top equals to size -1. So we can say stock is full. Stock is full. Then we terminate. We terminate here. That means we return. So this is the these are the steps to check whether stock is full or not. Suppose if it is not full, we increment top, and we insert data there. So we say here plus top equals to item. So this is the push operation in C. And when I take pop operation, so these are the steps. So push always moves the data item into the stock. So initially, suppose if I take this data structure, suppose as I told you, I gave you, there are, suppose size is 5 here. So size 5, and top is -1. So when I say push 20, so 20 will go into item. So top is not size -1. So this is incremented. This is incremented to 0. Then 20 is moved here. Then suppose if I continue this with some more operations, like push 45. So top is made 1. So 45 is kept here because this is 0, 1, 2, 3, 4. Now suppose if I say push 25. So top is made 2. So 25 is added here. Now suppose if I say push 15. So this is 3 and 15 is pushed here. Now suppose if I say push 30. So this is made 4, 30 is pushed here. Now if I try to push now again some other item, suppose if I say 35, because now top is 4, which is equals to size minus 1. So it says stock full error message. So this is push operation related with the stock. Now, similarly, when I take pop operation, so if I take the algorithm or steps for pop operation, so in case of pop operation, the first thing what you have to do is check whether stock is empty or not. Stock is empty or not. Because if stock is empty, there is nothing to pop. Stock is empty or not. So as part of this, suppose if it is empty, if stock is empty, then again we have to display some error message. Display some error message. And end the activity because there is nothing to pop. So we end the activity here. We'll say 1.1.2 end. Now, if suppose if it is not empty, then what we have to do is move the current item into the stock. Move current item into the stock. Then decrement top. So it is, that's why I'm saying top minus minus. First, in the position as indicated by top, we get the item and move it into the variable item. Then top is decremented. So this is the operation we do it. Now suppose if I take the same thing here, we have to take return some value pop. And here you check, the first step is check whether stock is empty. Stock is empty, we can know with top minus 1. If top minus 1, will say return some invalid item. So this generally we go for the least number. For example, I can say hash define invalid item as minus 2147483647. It is least, sorry, 48, least negative integer. So that I am taking because any other value may be part of the stock. So that's why I'm not taking. And the least possible integer, I'll ensure that it is not part of the stock and not part of the stock, and it will be used as invalid item. So that is invalid item, and before that you display some error message saying that stock is empty. Stock is empty. If it is not actually, suppose if it is not empty, then we have to take some variable item. So item equals to stock top minus minus. Then we have to return item. So this is how we pop. This is how we pop the stock. So this is the array or linear implementation of stock. Now, when it is linked implementation of stock, what we have to do is we have to go for linked list. So linked list, the linked implementation is actually slightly complex because it is related with pointers, and we have to have a node. So in linked implementation, the node will have two parts. One is data part, another is link part. So data part will be pointing, data part will be having the data of the data item, data of the of data item or the node, data of node, and link part will be pointing to next node, pointing to next node in the link, next node in the series, next node. So this is actually how we use it. So in linked representation, what we have to do is actually we if it is C, we go for self-referential structure for linked representation, and to avoid the repetition of the keywords struct. So we say typed of struct, we can say something like node. Here we say int data, which is data part of it, and the pointer is generally we go for next. Name of the pointer generally we go for next, because this is struct node. This node refers one of refers in next, with the help of next, it refers similar kind of node. So it is self-referential structure. So this is node we use it. So this node we use it to declare. We say node something like ND or top node, the pointer, because when it is stock we use only top as pointer. So we take top node top here, which will be generally initially it is made null. Initially it is made null. So top null indicates that the stock is empty. So when you take the operations like push operation, when I take push here with stock with the linked representation, so there will be item present. So these the steps are same, but each step the way we write it different because it is linked representation. So check whether stock here, mostly stock is not uh, will not be full, but anyhow it is always better to check. We'll take a node like node equals to some PTR and allot memory area. So node pointer, we allot memory area. So like malloc size of node. So we allot memory area, and if PTR is null, we can say stock is full. If PTR is null, it happens very rarely because the entire memory will be at the disposal of the program. So if PTR is null, we say printf recording. So if PTR is null, we say stock is full. Stock is full, and we stop the function. If it is not null, that means it is not stock full error. So then what we do is now we have a link here. We have to set the continue the link. So what we can do is here I'll write the logic, then explain. Suppose what we do is PTR next, PTR next equals to PTR next equals to top, and top equals to PTR. This is how, because always the recently filled location will be at the top. So this is the push operation. Suppose initially top is null. So we create a new node pointer. This is PTR. And sorry, one step here is we have to add PTR PTR data equals to item, item whatever we are passing. So the item is kept here. We are keeping the item here. Memory is allotted, and stock top is PTR next is top we are assigning. So this will be null because this is the first node. Then now top will be pointing to this. This is not null. It will be pointing to this. Now next time when I call, then suppose assume that this is 2000 here. So the top will be having 2000 and pointing to this. Top will be having 2000 and pointing to this. Now suppose if I create next node, this will be PTR, and the address assume that this is 3000. Now what we are doing, PTR, we are moving data into this, assume that data is 40. Now when I say PTR next equals to top, so 2000 will be stored here. So a link is set to this. Then top equals to PTR. Now top is changed to 300. Now top, sorry, 3000, it will be pointing to this. That's how the stock is keep on built when it is linked representation. So this is the linked representation of stock pushing the item. Now when it is a popping item, so when I take pop item, so int same logic you can write. The steps remain same, like in any algorithm, steps remain same. So we take int pop. Now, first you check if stock is empty, that we can say top equals to null. Then there is no item in the stock. We can say printf stock is empty. Stock is empty. Then we can return invalid item like what I gave earlier, because we are when we specify return type, we are it is expected to return something. It is better always to return, even though it is not compulsory in C. Invalid item, so that I am returning. Otherwise, what we do is we'll declare an item here, and item equals to stock. Item equals to, what we do is top whatever is there, so top data we keep here. Then we also declare a pointer so that we can release that pointer. So top data is moved into item because we have to return that item. And PTR, we are making it to top. PTR points to top because we will not be losing that pointer. Then we have to move top to point to the next item. Top equals to top next. Now this PTR is free to release, so we'll release the PTR. This is important. We have to release the memory. Then we can return the item. We can return item. So this is what happening. Suppose assume that this is the data structure. We have pushed some items in this order. So 50 is pushed first, then 30 is pushed next. Suppose 40 is pushed. This is pointing to this. This is pointing to this. This is null, and this is top. So when I pop first at 40 should go. So item will be top data. So 40 will go here. Next, PTR equals to item. So PTR will be pointing to this. Suppose assume that this is 4,000 and this is 3,000. This is 3,600. So 3,000 will be here. 3,600 will be here. This is null. So PTR is pointing to this. Now this is the node to be deleted. So I move top to the next. So top is earlier here 4,000. Now it is no more linked to this. Now this is removed, and 3,000 is kept. When 3,000 is kept, then top will be pointing to this. Now free PTR means this will be deleted. Now top is pointing to the next, and we return item. So 40 is returned. If I repeat this again, now item will be 30, and top PTR will be pointing to this. Then PTR is pointing to this because PTR will be 3,000. Top is made to point to next one, which is 3,600. So top will be pointing to this. Top is pointing to this. Now this is PTR is pointing here. PTR is pointing here. Now this is released. Now top is pointing to the last node. Then again, when I call this, this will be 50, and PTR is pointing, made to point to this. Then top next means top becomes null to indicate that it is empty, because just now the last node is deleted. Then we are releasing this. Now again, if I try to delete, because top is null, it says stock empty error. So this is how the stock is used in stock is actually operated. Like push and pop operations are the important operation of the stock. That's how we operate the stock. So one application I want to give it before we take some problems related with stock, that is actually arithmetic expression. So before we see how the arithmetic expression is converted using logic with the help of stock data structure, it is always better to represent this to represent it manually, and we understand this. Suppose if I take some expression like suppose some expression a plus b into c divided by d minus e, something like this. So this expression, what we have to do is before we use stock to convert it using some logic. So manually what we have to do is we have to build a tree here. So take all the operands a, b, c, d and e. Then as per the rules of evaluation of arithmetic expression, you keep on build the tree. So in the evaluation of arithmetic expression, what actually done is first the operation whatever is there inside the inside parenthesis, that is evaluated first. So d minus e is performed first, then next b into c is performed as per this operation, because asterisk and slash are having same priority. So when there are there is more than one operator with same priority, the evaluation is from left to right. Then this is division is performed, finally plus is performed. So this is the tree we get it. And now if I want postfix expression, so I have to go for left node first, then right node, then root. So left, right and root. So first a I'll take, then go left. Left is a tree, go left, again a tree. So go left, b, c asterisk, this is over now. Then go right, which is a tree, de minus, then slash, then plus. This is the postfix expression. Now, similarly, when I take prefix expression, first left, then root, prefix expression, first root, then left and right, So it is A, B, so first left, go right, again subtree, go left, then again subtree, B, C asterisk, left is over, go right, again subtree, D, E minus, then left right is over, then operator slash, sorry, something mistake I did here. So it is prefix first go root, so plus, go left, go right first again root, slash, go left again root, then left and right, so BC, then go right, there is again root. So this is the operation, the prefix notation of this expression. So this is infix expression. Then the postfix expression is this, and the prefix expression is this. So this is how we do it, and we can do this using stock. We can do this using stock. So that's how we perform, and using stock, the algorithm, the steps we'll discuss in the next session. I think we'll stop the session, then we'll continue in the next session.